Hi, Ida here. I'm making this video to convince Roblox developers and even normal players to stop using Roblox and start using the Unreal game engine. I used to be a Roblox developer in some pretty high circles, so you can trust me as a credible source. If you want to skip past the boring parts of the video, the timestamps for everything will be on screen right now. This is part 1 of 2 of the video, showcasing the features of the Unreal engine. Our game plan for this part is to first explore Unreal and then go into the technicalities of how it works, generally. So without further ado, let's get started. Let's do the guided tour. So introduction to Unreal Engine, launch it. Now, it does take a while to load, but once it does, you're exposed to all of its amazing features. So everything is running really smoothly, surprisingly. I have to keep my right mouse button down so I can actually move around, which is kind of annoying. There's also like this weird acceleration deceleration thingy. At each station of this tutorial, learn how to edit the world and see how your changes affect the game experience. On your left is a handy written companion. And I don't see anything on my left. Oh, they mean like this thing over here. Okay. Wait, I don't like this. I like it better in like Roblox when you have like a little dots on top and like on the sides. You can like drag them because this scales on both sides. So content drawer. So you can add objects to the world from content drawer in the bottom left corner. So there's some meshes and you can drag them to get across this gap. Details panel. So there's no collision on this thing. I don't think I'm gonna try to test that out because it's probably like void or something under this. So basic like properties in Studio. Outliner. There's a hidden object. I see. There's an invisible wall. Ooh. You know, there's actually a module on Roblox that would give this exact same effect, where like the force field would like fade out on the sides, and they just have it inbuilt here. It's pretty cool. Okay, so just gotta click on that. Delete. Materials. Materials define how the surfaces or objects react to light. So I can change them or create them in the material editor. So details and double click its icon. So, ooh, some pretty nice bubbles. Yeah, ooh, that's a nice color. It's like bubble gum. Okay, so we can change this metallic. Ooh, and that's gonna start to give like a little reflection. And it can be rough while being metallic. Ooh, that's pretty nice. Move on to the particles, which is pretty awesome in itself. I mean, look at all these particles. They even have physics, and they have the trails. Oh, okay, let's do 1,000. Okay, 1,000 is doable. I'm gonna just save this and exit out. And oh my god, holy. Tell me that is not epic. Tell me that is not the coolest thing you've ever seen right here. Meta sounds. What the fudge? Oh, okay. So apparently, if I change this thing's random seed, it'll be like, it'll do something weird. It'll make it a different sound. So. Physics. Yeah, we know physics, man. What are these? Why are these cubes like levitating? Like, can I knock this ball to knock them over? Oh, I think these are like a rope. Oh. That's pretty interesting. Lighting. This room can get pretty dark. Press a light by holding down L and clicking left mouse button. So L and left mouse button. Oh, I got one. Yo, so I put this, it's still pretty dark though. I can like, intensity. Oh, that's how bright it is. Let's make this a nice blue. That's pretty nice. I like that. Like a light blue. And then source radius. That's just how big the light is. Move this up a little bit. Probably, or yeah, that's pretty good. Soft source radius. I don't know what that is. Source length. Oh, animation. Oh, this is my character. So if I move side, he moves side. Whoa. Yo. Okay. This finally convinced me. This is 100% the best thing that's ever existed. Okay. Sequencer. So this is like, oh, we have like a little cutscene. Yeah, that's pretty cool. It like loads in all the shadows correctly too. Blueprint. A visual scripting language. I need to create logic and manage events like the switch that unlocks a door. I need to make the light above the door work like the other lights. Okay, wait a second. Click. Okay, yeah, wait, that one up there does not activate. Ooh, edit in blueprints. I see you. Let's open this blueprint up. And, okay, dang. This is like very similar to like DaVinci Resolve, you know, how you have like these things where you put the arrows into each other. It's pretty cool. Templates, okay. Check those out. And we got, wait, you see how it's like the image moves around? This is a static image, so it isn't like a viewport into like another thing, but it still does that. This is like, you know, the Roblox portals. Wait, me in the future editing, put it on screen, like the Roblox portals where you look side to side, the image will move. Yeah, it's kind of like those. Whoa, bounce. I think that was a glitch in the physics, but hello? I don't think there's any respawn. I think you have to code in the respawn. Respawning is not a built-in option. It's just like in real life. Okay, phew. Now that we've gone through the guided tour, we can finally explore the technicalities of how Unreal Engine works. Okay, let's start with the basics. Unreal Engine uses two coding languages, C++ and Blueprint. C++ is widely considered to be the best, highest level compiled programming language. A compiled programming language is a language that takes some time to optimize itself before actually executing. Blueprint is the visual language you saw earlier with the boxes and arrows connecting them. It's an interpreted language based off Simulink. An interpreted programming language is a language that instantly runs and does not take time to optimize. Next is features. I'm not going to list every single feature Unreal Engine has because that'd take way too long, but it does have almost every single feature you can think of, even down to fluid simulation and inverse kinematics. Next, let's talk about multiplayer on Unreal Engine. Usually, the way multiplayer would work is that the client, which are the player's devices, would connect to a central server. The server would host the game state, which is the player positions, scores, and other stuff, and then the clients would send their actions to the server. The server validates their actions, updates the game, and sends the updated state back to all the clients. However, Unreal does not provide servers, so you have to either make it so that there is no server and the client just send actions to each other and simulate everything themselves, or you can have it so one of the clients act as a server. This is now part 2 of the video. In this part, we will be exploring how Roblox works, comparing Unreal to Roblox, and slandering the Roblox dev community. Let's get into it. Okay, so let's start with how Roblox works. Roblox uses a programming language called Lua U. It's an upgraded version of Lua, which was a scripting language created in Brazil. Lua U is faster than Lua, it has more features, and every Lua program also functions as a Lua U program. Lua is interpreted, which means it's also very simple and easy to code in. Next, let's talk about features. Roblox is a very primitive game engine, so it doesn't really have that many interesting features to boast of. As you can see, the Roblox equivalents of the examples I showed on screen for Unreal aren't that impressive. Multiplayer. Roblox provides servers for multiplayer, and all the networking is done for you. They even provide a lot of functions so you can use it properly, like network ownership and server and client-side scripts. However, it's very easy to exploit in Roblox, meaning you're going to have to write your own anti-cheats if you want to stop exploiting your game. Let me explain Roblox server-client networking in a nutshell. Let's do an example of a player and a part. Originally, all the calculations for the part's physics are being done by the server. But if the player touches the part, then the player will start doing the calculations for the part's physics. This is called network ownership, and the person simulating the physics for the part is the network owner. Now, you might ask what having multiple players interacting with the same object would do. The answer is that it can get very glitchy, especially with multiple players standing on the sphere. Okay, so now that we've examined Roblox and Unreal, let's compare them. Roblox uses Lua U, while Unreal uses C++ and Blueprint. Lua U is easier to learn, while C++ and Blueprint are more efficient. Neither option is much better, arguably, though. Next, Roblox has less features while Unreal has more features. Unreal is obviously better in this aspect. Roblox uses server-client networking, but it's easy to exploit in, while Unreal is client only. Neither option is really much better here. And Roblox games only work in the Roblox app, while Unreal games work as in .exe and need to be downloaded. Neither option is much better here. Roblox has a simple interface and workflow, while Unreal is much more complicated. Roblox is better than this aspect. It's also very easy to get commissions in Roblox, but they pay less, while with Unreal, you have to get into complicated contracts, and although they pay more, neither is much better in this aspect. And if you're still not convinced of the superiority of Unreal, then just watch this. Hello everybody, this is your daily dose of Roblox development. I hope you enjoyed the video. Please like and subscribe if you enjoyed it. And if you didn't enjoy it, forget what you just saw and maybe you'll enjoy my next video. Bye!